All right, let's continue our discussion with functions in lesson 3.1, video 2 here. Now, this question asks, is the relation a function, and gives us a set of 4 ordered pairs. Now, on I think the second slide, we talked about the definition of a function. So let's talk about it right down here. So remember, if a relation is a function, then that means that each x is assigned or mapped onto only one y. Right? You are not a function. You are not a function if one x has 2 different y's. This is a no-no. Okay? All right, so a couple of things here. When you're given a list of ordered pairs, okay, remember they come in xy pairs. The first thing, and maybe the most simple thing, is look for repeated x values. So this is the first thing I'll tell you, right? Look for repeated x values. If you see repeated x values, it's probably not going to be a function because that repeated x value is going to have 2 different y values, right? But if you look here, your x's are 1, 5, 7, and 8. This is probably going to be a function because each x only occurs one time. Okay. The second thing you could do is I'll do it in blue. You could do a mapping, right? I like mappings. You can make an x column, and I like to put the numbers in numerical order. So 1, 5, 7, 8. You don't have to. So 1, 5, 7, 8. But if you are able to, and then over here for your y's, so 2, 6, -1, and 0 are my y's. So that would mean -1 would go here, then 0, and then 2 and 6. But again, you don't have to put them in numerical order at all. And now I'm going to map them. I'm going to draw arrows from the x's to their corresponding y's. So this one corresponds to a 2. This 5 corresponds to the 6. The 7 corresponds with the -1, and the 8 corresponds with the 0. And you can notice that each x only has one arrow going from it. So that also makes me believe that it is a function. The other thing we could do is we could graph it real fast. I'm going to show you on Desmos real fast how to graph, right? Again, using the Desmos tool to your benefit. So let me bring it up here. Not that one. We're going to use the testing one, right? Okay, so I always like to zoom out 1. And I have the ordered pairs right here next to me. So we're going to put in 1, 2. And we're going to put in 5, 6. And we're going to put in 7, -1. You could do these all in the same box if you wanted to. And I'm going to do 8, 0. So if we look here, for this not to be a function, you would have 2 points stacked on top of each other. For instance, you would have like a point like this and a point like this stacked on top of each other, where this x value of -5 would have 2 different y values, in this case 2 and 6. But that is not the case. If you look here, this x, or this point, this point, this point, this point, they're all separated. Nothing stacks on top. Therefore, this is going to be a function as well. Okay, so this is the graphical approach. All right. So if I come back to our notes here, so the third thing I will say in green here would be you could graph it. And really what you're looking for is you're looking for points that are vertical. So I'm going to put looking for vertical points. So for instance, a point like this and a point like this. And our example here was like if you have like a -5, 2 and a -5, 6, right? 2 points that have the same x value but different y's. If that was the case, this would also not be a function. But through all of these 3 ways to determine if it's a function or not, we determine that it is actually a function. So this is a function. This is a huge concept in Algebra 1 and on the state test. So please, please, please make sure you understand what it means to be a function. Okay. Next example here, example B, it says, is this relation a function? So notice here, this is a mapping diagram, right? So they gave it to us as a mapping diagram. So the first column is the x's because that's where the arrows are coming from, or the domains, if you will, right? Or the domain. And the second column is the y's. That's where the arrows are going to. Now notice here that there's 5 x values and only 3 y values. So you might be concerned, right? There's not the same number. That's okay. Again, we're still looking to see, do each x have its own y, have one y, not its own, one y, or do we have any x's that go to 2 separate y's? So if you look here at 1 and 2, right, look at these two, right? This x value of 1 goes to 17. It only has one y value. This x value of 2 goes to 17. It only has one y value. Who cares if they're the same y value? It's not about the y. It's about the x and the fact that each x only has one arrow. So this is okay. 3 goes to 11, 4 goes to 10, 5 goes to 10. It's okay. We have a function here. If I were to list these as ordered pairs, 117, 217, 311, 410, and 510. Notice that none of the x values repeat. And if I just graph these first two real fast, 117, that's kind of crazy, but just, so 1 and then 17 would be way up here, right? 117 and then 217. Notice that they are horizontal with each other. Horizontal is okay, right? Vertical is not. Stacked is not. Horizontal is okay. So this all tells us that the relationship here, the relation, is also a function. Perfect. Okay. Last but not least here. Example 4. It says the diagram shows shipping charges as a function of the weight of several online orders. Based on this situation, what constraints, if any, are on the domain of the function? So you have a mapping diagram over here, right? The weight of the order will be the input or the domain, and the shipping charge will be your output or your range. I love this statement right here. Shipping charges as a function of weight. Shipping charges as a function of weight. That means because you're a function of weight, that means that weight is the input. Weight is the x, and the shipping charge is the y. So get that verbiage down pat for this topic, right? Shipping charges as a function of. Okay. So if you look here, right, what would be any constraints on this domain, right? And again, we're looking on the weight. This is going to be where our domain comes from. Well, think about it. If you go to like a UPS or something and you drop off a package to mail, they're going to weigh it. And if you have a package, it's going to weigh some positive amount of weight, right? So we must include in the domain, so the domain must include values greater than 0. And again, that would be the weight in pounds, greater than 0. So there's a couple different ways to write this, but we're going to use inequality notation. So your domain, and you'll see this in Savis, there'll be like a capital D for domain, and then these braces. We're going to say x is greater than 0. That would just be it. Now you might also see x is greater than or equal to 0. Again, that's okay too. But if a package weighed 0, that means you didn't have a package, right? So that doesn't, really mean anything to us. Again, no negatives though, no negatives. And again, this is going to be typical for your real life problems. Real life problems. Now, in fact here, and just to take it a step further, the range would be the exact same thing, right? Now, ranges are y's. The shipping charges would also be greater than 0 because you have a standard shipping charge, right, for what a package weighs, and and once you weigh the package, you're going to incur some sort of charge. So it's also going to be greater than 0. And again, it could be equal to 0. So that is why when we do word problems, you'll see that we only graph on the positive first quadrant, right? This L shape where 0 starts here and we're positive x values and positive y values. So this is why that is the coordinate plane you see on word problems. All right, great. Good talk about domain, range, functions. This is a very, very key section. Hopefully you understand this vocab and get it all down pat. All right, see you in class.